In this video, we are going to see the products of metallic powders. Okay, powder metallurgy process. Before the I will start with the previous day. So, powder metallurgy process. Okay. Initially, the powder metallurgy is the art and science of producing a metallic and metal and metallic powders, and using them to make a finished or semi-finished product. So initially, our humanity will be used to make the product. Only this is the processing process. This is the formation or fabrication process for making a product. Okay, particular technology is probably is the old farming technique. This is the old farming technique and well known by a human. Uh, we are having the archaeology evidence also. Okay, then the entire in this method the entire material need not to be melted and fused. Okay, their working temperature is well below the melting point of the major constituent, making it a very suitable method to work with refractory material such as tungsten, molybdenum, Ta, Nb, and oxides and carbonates, etc. It begins with the platinum technology about 4 centuries ago itself. It will be started. Okay, in those days, platinum MP that is equal to 1700 degrees Celsius. It was refractory and could not be melted. Okay, it very important. It could not be melted. Okay, then the process. What are the process they were used? Initially, their powders are powders and additives are mixed with one part. Then after that. The blending and mixing will be happened. After that, the compacting process, powder compaction process will be taken place. After that, after this process, the sintering they will consider as a sintering process. Then the secondary operation part, making as a final product, Then they are given the finished product parts. Finally, they get as a finished product part. Here you can see this the raw powder will be taken. After the raw powder, after putting the raw powder, the formed product. The formed product will be taken down. Then after the formed product contain of the formed product will be given or we have to taken to the sintering. Okay, here the picture shows the sintered product. Then here you can see this first initially the powder will be powder fabrication, size and shape characteristics, because sometimes the size is very important for getting the better properties. Okay, then microstructures defining the how the shape and size will be available. Then chemical homogeneity will be there. After that, compaction and sintering, these are the process we will be making as a product. Okay, for making a product or whatever the property we required, we are making as a product. Even though sometimes purging or art pressing will be process will be taken place. Then final properties we are going to calculate based on the density, porosity, and ductility, strength as well as conductivity also. Other functions will be calculated after finding the product. Then and blending and mixing will be taken place. Here you can see this. Here the blending and mixing will be taking place. This is the rotating drum, blade and screw mixers will be available for mixing the various combination of the various composition of the powders. Okay, after that pressing. Okay, powders are compressed into desired shape. Okay, we are compressed into desired to make a green compact. Produce a green compact accomplished in a press using punch and die tooling designed for the part. Then sintering. Here in this the third one is showing that sintering. Here green compact are heated to bond a particle into hard shape. We are making hard and rigid shape, rigid mass shape, performed at a temperatures below the melting point. All the works will be done below the melting point of the particular metal. Then in general, procedure of metallic powders are not the same companies as the PM powder metallurgy parts. Okay, any metal can be made into the powder form. Okay, after that the three principal method by which metallic powders are commercially produced: atomization by gas, water, also centrifugal one, then chemical and electrolytic. In addition, mechanical methods are occasionally used to reduce the powder size. Okay, some of the mechanical methods are there. In the nanotechnology, in the nanotechnology process, we can see the various mechanical addition process. Okay, milling addition process is the one of the mechanical method. Okay, after that, here you can see this. After that, the particle shapes in metal powder. Here you can see this. The chemical decomposition, irregular rod like, then flake, then dendritic, then various shapes are three-dimensional shapes, one-dimensional shapes, two-dimensional shapes are they were given. Okay, these are the various shapes, particle shapes available in the metal powders. Then all these powders are mixed in the mixer. Then after the mixture, the blending will be taken place. Blending or mixing will be taken place. Then compacting process will be considered by pressing the powders. After that, the sintering process will be taken. Sinter or consolidation at high temperature will be taken. Blending and mixing of powders. Okay, for successful result in compaction and sintering, the starting powder must be homogeneous, making as a single powder should be blended and mixed. Blending, okay, powders of same chemistry, but possibly different particle size are intermingled. Okay, different particle here you can see different sizes are intermingled. Different particle sizes are often blended to reduce the porosity. Mixing powders, okay, mixing powders of different chemistries are combined. The metallurgy technology allows mixing various metals into alloys that would be difficult or impossible to produce by other means. Okay, then blending and mixing, the continuous only we are going to see in this slide. Blending a coarse fraction with a finer fraction ensures that the interstices, okay, interstices between large particles will be filled out. Powders of different metals and other materials may be mixed in order to impart special physical and mechanical properties through the metallic alloying. Lubricants may be mixed to improve the powder flow characteristic. Binders such as wax and also the thermoplastic polymers are added to improve the green strength. Okay, then blending to make a homogeneous mass with a uniform distribution of particle size and composition. That is a very important point. Then here the powders are made by different process, have different sizes. Okay, we already saw the different sizes of powder sizes. We saw that will be converted as then will be make as a homogeneous part and shapes. Here different sizes and shapes. Mixing powders of different metals and materials. Okay, combining is generally carried out in air and or inert gas to avoid oxidation. Liquids for better mixing, elimination of dusters and reduced explosion in explosion hazard. Here you can see this blending component. Okay, a mixture suitable for blending metal powder. Here various types of various common geometries used to blending the powders. Here you can see this is the cylindrical shape used to rotating, making as a blending process. Here the rotating cube and double cone and the twin cell. These four geometry equipments are used to making a blending of powders. Then compaction, application of high pressure to the powders to form them into a required shape. High pressure, we are using the high pressure to make a required shape. Conventional compaction method is pressing is the process, okay, which opposing punches squeezing the powder contained in a die. Okay, then the work part after pressing is called as the green compact. So after the compaction process, we are getting the green part is compact is the product. Okay, the word green meaning is not yet fully processed. So that means the intermediate product. The green strength of the part when pressed is adequate for handling, but far less than after sintering. Here you can see this the metal. Okay, initially in the right direction shows the compaction of the part pressure. Compaction due to the pressure, we will be making as a compact. Press powder into the desired shape and size in dies using a hydraulic or mechanical press. Pressed powder is known as the green compact. So here the various stages is explained. Okay, the various stages will be explained. Then powders do not flow like a liquid. Okay, it is okay. They are simply compressed until an equal or opposite forces is created. Uh, we saw that in the previous slide. It's not a liquid shape, so it will be making as a bulk formation, like a bulk formation, not fully bulk formation. This opposing force is created from the combination of resistance by the bottom punch or fraction between the particles and the die surface. Compacting, consolidated and dandified. Okay, the compound for transportation to the sintering. Okay, sintering furnace. Compacting consists of the automatically feeding a controlled amount of mixed powder into a precision die after which is compacted. Here the compact, okay, pressing cycle, showing that the pressing cycle. Okay, initially the metal powder, okay, will be there. Then adding the metal powder, then the pressing the metal powder taking place. Here the die is upward direction. Then here you can see this ejecting the compact. Okay, ejecting the compact, the pushing the compact outside. Here you can see this ejecting the compact. It will be, this is the compact process. It will be sending out. Okay, then this process will be consists of taken place in the 10 tons per square inches and 138 megapascal to 6 ton. Okay, 60 tons per inch square, 827 megapascal or more. Okay, here you can see this, the compact process will be taken. Okay, pressing. Then the compact sequences will be explained. We already saw the compact sequences. First the cycles will be started here. Okay, this is the punch, die, and once again the punch or downward direction punch. The feed show will be taken place after the charging with the die powder, filling the die powder. Then compaction began. Here the compaction will be taken place. After the compaction completed, the eject part, the die will be move upward. The punch will be move upward direction. Okay, with the help of this punch, downward punch. Okay, then after that the ejection part will be ejecting the compact, then recharging the die. Okay, the friction problem in a cold compaction. Here you can see the friction problem in a cold compaction, the same process. Then the sintering process. Here heat treatment to bonded the metallic particles, thereby increasing the strength and hardness. Okay, heat treatment to make a bond, to give the bond to the metallic particle, that will be increasing the strength and hardness. Usually carried out between 70 to 90% of the melting point. Okay, so only 70 to 90% we will consider for this. Generally agreed among the researchers that the primary driving forces for sintering is reduction of the surface energy. Surface energy will be reduced in this process. Part sinkage occur during the sintering due to the pore size reduction. Yes, small size will be reduction will be taken in this sintering process. Here you can see this, the sintering process will be given in the picture. Parts are heated 80% of melting temperature here in this diagram. So the transforms compacted mechanical bonds to much stronger metal bonds. It gives the much stronger metal bond. Many parts are done at this stage. Some will require additional processing. Here you can see this sintering sequences. Okay, in this slide we are going to see the shrinking sequences. Here this is the green compact. Next, neck formed after the porous size. Then porous size will be removed with the help of this. Then the fully sintered part will be achieved. Parts are heated up to 70 to 90% of the melting point. Transform compacted mechanical bonds to much stronger mechanical bond. So up to sintering sequences we saw in this video. Then the continuous of sintering process will be in the upcoming video.